Hello everyone, my name is Aditya. My roll number 21BQ1805F6 from 2CSCC. Now I am here to explain about mathematical expectation variance in probability. This is our title, The Power of Probability Unleashing the Secrets of Mathematical Expectation and Variance. In this video, we are going to talk about Introduction to Mathematical Expectation and Variance. We have taken two examples, rolling a fair die, rolling a Faraday continuation, and the next slide. Second problem is tossing a based coin, biased coding. Then the continuation of that in the next slide. Tossing a based coin continuation. First, introduction. Introduction to mathematical expectation variance. Probability theory is a branch of mathematics. Now we are explaining about probability. Probability theory is a branch of mathematics that deals with the study of random events. It is used in various fields like finance, physics, engineering, and many more. As we have seen, there are so many applications of probability. One of the important concepts of probability theory is mathematical expectation variance. This is one of the main topic. Mathematical expectation is the average value that we expect to get from an experiment, while variance is measures how much the outcomes of an experiment vary. We have definitions for mathematical expectation. It is the average value that we expect to get from an experiment, while variance definition measures how much the outcomes of an experiment vary. The mathematical expectation of a random variable x denoted by E of x. It is notation E of x. It is meant for expectation and is given by the formula E of x equal to sigma x p of x, where x represents all the possible values that x can take, and p of x represents the probability of x taking the value of x. That means here x represents possible values. Suppose we have taken a coin, then that means possible values are either head or tail. Here p of x represents the probability of x taking the value of x. That means suppose p of x, here x means tails, then it is called probability of x, whether the value x is head or tail. The variance of x is denoted by var of x. It is the notation and is given by the formula here. Variance of x is equal to E of x minus mu square. Here mu means expectation. Here E means expectation, mu means mean, where mu is the mean of x. We have seen the probability and the advantages of probability, definitions of expectation, variance, and notation of mathematical expectation, formula for mathematical expectation, notation of variance, and the formula for variance. Let us see with some examples. First, we have a rolling a fair die. Let's say we roll a fair die. That means the possible outcomes are 1, 2, 3, 4, 5, 6, and each with a probability of 1 by 6. The random variable x represents the outcome of the roll. That means it can be any of the value, any of the number. That means 1 to 6. We can find mathematical expectation of x as follows. Here f x is equal to 1. That means number into 1 by 6 plus 2 into probability plus 3 into probability of that outcome plus 4 into probability of that outcome plus 5 into probability of that outcome plus 6 into probability of that outcome. The expectation came as 3.5. Now let's see variance for the rolling a fair day. On average, we expect that the get a value of 3.5 when we roll a fair day. Now let's find variance of x. We have no variance of x formula. Expectation of x minus mu square. That means we can simplify this by we have no expectation and mu value. On substituting, we get the value as 2.9 to similar. That much value is welcome. So we have seen variance and mathematical expectation for Faraday. In the second example, we are going to see about coin. Consider a based coin that means that has probability of 0.7 of landing heads and probability of 0.3 of landing tails. That means here the probability is not same for head and tail because it is a biased coin. Let x be the random variable that represents the number of times we get heads in two tosses of the coin. We can find the mathematical expectation of x as follows. E of x equal to 0 into 0.09 plus 1 into 0.42 minus 2 into 0.49. It is expectation. On calculating we will get 1.4. Example 2 continuation. In the previous slide we have calculated mathematical expectation, and we have in this we are going to calculate variance of x. On average we expect to get 1.4 heads in two tosses of the biased coin. Now let's find the variance of x. It is formula expectation of x minus mu square. On substituting the values according to the previous slide, we will get the value of variance of x as 0.56. Conclusion. We are at the end of this video. Now I am going to conclude about this topic. Mathematical expectation and variance are important concepts in probability theory. They help us understand the behavior of random variables and make predictions about the outcomes of experiments. By calculating these values, we can determine the average value we expect to get from an experiment and how much the outcome of the experiment vary. These concepts have practical applications in many fields, including finance, physics, and engineering. These are fields in which we use probability. In conclusion, understanding mathematical expectation variance is crucial for anyone interested in probability theory and working with random events. By mastering these concepts, you can give valuable insights into the world around us and make better decisions based on the data and statistics. That's all for this video. We have seen pretty much about mathematical expectation and variance of. Thank you.